Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the context-free grammar. So here we will prove that whether the given language is a context-free grammar or not through the pumping lemma. So in the previous videos, we already discussed about what is meant by context-free grammar and how to minimize the context-free grammar and what is the normalization steps and how many types of normal forms we have for the context-free grammar. And in this video, I would like to explain about the language. The given language is a given context-free grammar or context-free language or not. We'll check through the pumping lemma concept. So here we will move to the slides. So what is meant by pumping lemma? So here the pumping lemma which is used for to derive the given language is a context-free language or not. We have to check with the pumping lemma. So here a CFL is a language generated by the context-free grammar. So here CFL context-free language which is generated by the context-free grammar. And here the pumping lemma is used to prove that certain languages are not context-free. So here this is only the pumping lemma which is used to only the given language is not a certain languages are not a context-free or not. It is a negative test whether the language is context-free or not. So it is only a negative test. With this pumping lemma, we can't prove that it is only a context-free language. With the pumping lemma, we can say that this context-free grammar is not a grammar, the context-free language. So let L be any CFL context-free language L. Then choose a string Z such that the length of Z is modulus of Z greater than or equal to N. So here the string, whether in the given language, we will form a string. So in that the string length should be greater than or equal to pumping length. N is nothing but it is a pumping length. And these are the conditions we have to take further to prove that the given language is not a context-free grammar. And using pumping lemma, we can divide that Z. Z is nothing but the given string. With the given language, we can form a string. So that name of the string is here Z. So we are dividing that Z into a 5 parts. So that Z is like, we have to divide this into a 5 parts like U, V, W, X, Y, Z. So here like that we have to divide that into a part. 5 parts, and the conditions are here. We have the conditions. We have to divide the string into a 5 parts. Then in that 5 parts we have to take 1, 2, 3 steps, 3 parts, and we have to give the conditions for this one. So what are the conditions in this one? V W X modulus of V W X less than or equal to N, and V X modulus of V X greater than or equal to 1, and for all I greater than or equal to 0, so the Z is nothing but here the string. So we have to check this entire 5 parts. The string is divided into 5 parts, and we have to give the pumping length I some value to that one. In case after the value is given, we have to extract that string, and we will check whether the after extraction also, if we got the same type of language after the extraction, we can say that this language is going to be a context-free language. So with these are the conditions we have to satisfy to prove that the given language is a context-free language. And next, so here the to prove that the language is not context-free using pumping lemma, we have to follow the steps. So assume that A is a context-free. So here we have with the examples we will explain. So here L is equal to nothing but 0 power N 1 power. This is the example just I am taking. So here this is the language, given language. In this language 0 and 1 are the inputs. So with this we can form a string. So how we can form a string for the given language in the sense? So here N we will take 2 So here 0 power 2 and 1 power 2. So what we will get? 0, 0, 1, 1. So this is a string. So we can name it as A. So here we will name it as A. And here in the second step, it has to have a pumping length P. So pumping length P. So if you give P here, n is equal to 2 like that, we will form n is equal to 3. We will get the string like this. So here this is the n pumping length P. All the strings longer than P can be pumped, and here the S is nothing but this entire string is named as a string S, and the length of the string. So if you count the length, modulus of S is nothing but if you count the number of integers involved in the string is 6. So here the modulus of 6 is greater than or equal to P is nothing but what we have taken, n is equal to 3. So this condition is satisfying. So like that we have to take the string from the given language and with the pumping length P. Now find a string S in A such that modulus of S greater than or equal to P. Just now we discussed the string length is 6 and greater than or equal to pumping length. The pumping length is 3. So it is satisfying. Like that we have to take the string from the given language and divide the S into 5 parts. So here we are dividing the parts, dividing the string. So this is the string we have to divide. So here if you take the P is equal to 3 and what is the string here? 0, 0, 0, 1, 1, 1. So this is the string. In this one we have to divide into a 5 parts. So here I am dividing this 0 as a 1 U and V and X, Y and Z. So here we are taking this into a 5 parts, and after dividing this string into a 5 parts, show that V power I, X, Y, I power and Z belongs to A. It does not belongs to A for some I. So here we have to take V power I. So V power I, V here U is equal to 0 and V is equal to 0. And X is equal to 0, 1 and Y is equal to 0 and Z is equal to 1. So here U V power I, X, Y power I and Z. So here V is nothing but here we have 0, 0 square. Here I is equal to, if you take some I, so I value you will take 2 and we will do the extraction. So X is nothing but here 0, 1 and Y is equal to 0 and 0 I power 0 power 2 and Z is equal to 1. So Y is equal to 1. Y is equal to 1. And here also Y is equal to 1. And here after extraction 0 square in this is 0, 0, 0, 1, 1 square 1, 1, 1. So what we got? 0 power 4 and 1 power 4. So like this we can extract this one and we will check this given language is regular or not, context free or not. So then consider the ways that S can be divided into X, U, V, phi tuple. So here U, V, W, X, Y. So we have to divide like this the string and now show that the thing is satisfying the 3 conditions or not. We will check the what are the 3 conditions in the sense. Here we have to satisfy these 3 conditions. Then you will prove that the given language is a context-free grammar, context-free language or not. And we will discuss it with more example. So here we have taken the example X power N, Y power N and Z power N. So here the language which is forming with the combinations of 3 inputs and N we are taking one value N greater than or equal to 1. So here first step, what we have to do in this sense, we have to let the L be the context free, let must pumping length say N. So here N is equal to greater than or equal to 1 is there. So here, so greater than or equal to 1, we have to take the N values. And first step, what we have to do, we have to take the string, assumption of the string. So with the pumping length N is equal to, here we are taking the N is equal to 4. So here we are taking the N is equal to 4, pumping length N is equal to 4, and we will divide that into a string 5 parts. So how we have to look? So here S is nothing but the string which we have taken from the language, and here N is equal to 4. So X, 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 and Y, 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 and Z, Z, so Z. So here also we will name it as a all capital letters. Why? Because we are again the string is divided into a 5 parts. So in that 5 parts we have X, Y, Z also. So here we have elaborated this with the pumping length N is equal to 4, and in the next step, what we have to do, we have many cases, like we have to take the values of this V and Y values. So here the V and Y are the most important. Why? Because see here, if you observe the condition U V power I, X, Y power I, and Z. So these the two are the powers we have in the equation. So in this one, if you give the value of for this divided part, we will the string is going to be changed. So that's why by taking these two values, dividing that string into these 5 parts, these two values are the most important things. So in that case, so here we have divided into cases like choosing these two values. And here in the first case of this example, we have to take this V and so here V and Y are the two values, important values. So V and Y values contains only one symbol, one type symbols. So here we have 4 symbols here like X, Y, Z. So 3 symbols are there in this string. So in this string, while dividing that string into 5 parts, in this one, the V and Y values should have only a single value. So here 3 values are there. In the 3 values, only V contains only one single value, and Y contains only a single value. So how to divide this string? So let me take this string X, 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 Y, 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 and Z, 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 Z. And here the V and Y contains only a single value. So here we are taking this first X is a U, and second 2 X's, or name it as a V, and remaining all this Y and this Z, and this contains X. So here we are divided this into 5 parts. So in this one, this is a combination of, so the X we are taking, it is a combination of 3 symbols. So and here also we will take it as a Y and Z. And here if you have observed this one, and here this we are divided into V contains only two values. The 2 values are also a same value. And here the Y also, it is having the 2 Z's, and here it is also a single type of input. So here we have divided, this is one condition, in this condition, and we have to check for the 3 conditions. So first condition is So what is the first condition? The modulus of VWX. So here the VWX modulus of X is greater than or equal to N. So here, so VW, so VXY. So here the VXY is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the modulus of VXY and greater than or equal to, less than or equal to N. So here the N is nothing but 4. So 4. So here this is the 10. So 10, modulus of 10 greater than, dividing that into a 5 parts. So here first condition is satisfying, and the second condition is we have to check the V I power U V power I and X, Y and Z. So y power I. So here let me take I is equal to 2. So in that case, so here the U is equal to X and X square and X, Y, and Z square and Z. So here we will get X, Y, Z. And here the string which is not belongs to the given language. So here why? Because so x power 1, 2, 3, 4, 5, 6. So here the x power 6 is there and y 1, 2, 3, 4. So y power 4 and z power 6. So here which is not a language, given language. Why? Because so here x power, if you take the initially, so x power 4, y power 4, z power 4, the values of the powers are all equal. But after getting pumping length, we will have the result as a powers are not in equal. So that's why we can say that the given language is a not a context free language. So this is one case, and we will check for the second case. So in this second case, V and Y values. So V and Y values are, then this one kind of are either of V and Y. So either of V and Y values contains only one symbol. Either of V and Y values contains only one symbol. So this is one condition. So in this condition, same thing, we have to check for the, we have to divide that string into a 5 parts. So in that 5 parts also, let me check x. So 4, y, z. So this is the thing. So in this one, V and Y are the most important things. So here we will have to divide that x into a, this first x is u, and so here the first two x's, and this one is v, this one, and this x, and here also this x, y and z. And after this also, if you take V is equal to x, y. So in this one, if you give the V power I, x, y, z, y power I. So here I is equal to 2. What we will get? U as it is x, and V is equal to x, y, whole square, and x, y, z, and z square and z. So here after this entire result, we will get x, x x y y and x x y y and y y z z z z square z z z. So finally we have the result x power 4 and y square and x square and y power 4 and z power 6. So this is finally what we got. So this is not our pattern. So here our pattern is x power 4, y power 4 and z power 4. So here what we got in this final extraction we got, so x power 4 and y power 2. So again we got the x power 2. So this is not our pattern, so that the given language is not a context free language. So this is the how we have to take one example and how to show that the given language is not a context free language with the pumping lemma. And here we will take one more example. So here we have taken the language L, W is equal W, W. So here the W, which is a word which is formed by the two input symbols. So what are the two input symbols? 0, 1. So with the combinations of 0 and 1 inputs, we will form a word. So that is nothing but we can form a string. So here the string is also a combination of W, W dot W. So it's a concatenation. So W is the word which is followed by another word. So how with this one we can form a string. So how we have to form this first step is we have to form a string. So S is equal to, so S we have to take, and the W which is a combination of 0, 0, 1. So 0, 1. So one word and which is followed by the 0, 1. And here if you observe this one, so 0, 1, 0, 1, it is a combination of two words. So in this one the first step is we have to take the string from the given language, and after that we have to, second step is we have to give a pumping length P. So P is equal to, if you give the P is equal to 5 and 0 power P and 1 power P and 0 power P and 1 power P. So why? Because this is one part and this is W, W. So W, W. So it's a combination of 0, 1. So in that one we have to give the pumping length P is equal to 5. So here by using this pumping length value 5, we will form a string. So S is equal to 0 power 5. So 0 power 5, 0, 0, 0, 0. 1 power 5, 1, 1, 1. And 0 power 5, 0, 0, 0. And 1 power 5, 0. So this is how we form a string with the given language. And here first step we got done, and like we have to take the string and we have to give the pumping length for that one, and we will check whether the length of S greater than or equal to P. So P is equal to, it's a combination of 20, and so 20 greater than or equal to P is equal to 5. So this is condition satisfied. This is the first step we have to do for the pumping length of the context free grammar. And next here we have to divide this string into a 5 parts. So that 5 parts is also we have to take 2, 3 situations in that V and Y are the two values, important values. So how to select, how to divide that 5 parts into the string into a 5 parts. So here we will take first case. So in this first case we have to V and Y, V and V, X, Y. So this, in this case we will divide this 3 parts. V, X, Y does not straddle boundary. So here, So here with the string boundaries are nothing but here 0 power 5, this is one boundary, this is one boundary, and this is one boundary, this is one. So here 4 boundaries are there here. So in the given string, so we have the 4 boundaries. So in this kind of boundaries, so we have to select here 5 parts v, x, y. So in this vx, in this string, we have to select a part. So straddle does not have boundary. So does not have boundary in the sense. So within the single pattern, we have to take the vxy values. So here how to select this one. So here the 5 zeros, 1 1 1 1, and 5 zeros and 1 1 1 1. So here in this one y values we have to take. So here these are the 3 v, x, y values. So remaining, so it is a u and u, v, w, x, y. So 4 parts are divided, and this is also z part. So here like this v, x, y values. So how first step we have v, x, y values we have taken. So within the boundary, so this is one boundary, and this is one boundary, this is one boundary, and in this boundary, within the boundary we have selected these 3 values. So this is one case, and let me check with the given conditions are satisfying or not. So here in this one we will check v power I and x y power I and z. So here I is equal to 2 we will take in this one, and we will extract these values. So here v is equal to 1, so 1 power 2 and x as it is, and y also, sorry, y is equal to 1, so 1 power 2, and remaining z value I am writing as this. And so this is 6, so here we need only 5. So here after this one we got the equation 0 power 5 as it is, and 1 power 3 4 5 3 4 5 6 7. So 1 power 7 we got, and 0 power 5 we got, and 0 power 5 and 1 power 5. So what the pattern contains after this one, what we got, so here this is the pattern 0 power 5, 1 power 5 and 0 power 5 and 1 power 5. So after the value pumped, I value is pumped here. So what we got is I power 1 power 7. So the power values are not equal. So here which is not belongs to a context-free language. So given language is not a context-free language. So this is one case, and the second case is, so we have to take first case we have to took the values v, x, y values within the boundary. So here the first boundary we will take. So here in this one v, x, y straddles the first boundary. First boundary. So here we have to take the values. So here I am writing the string as it is. So here, and we will divide this into 5 parts. So here the first boundary, within the first boundary we have to divide. So here these first 2 zeros are u, and second, so in this one v, and the first straddle in this first boundary we have to select. So here in this first boundary, so this is one boundary, this is one boundary, and this is one. So in this boundary we have to select the values. So here one is x, and here y value So y value we are taking the two values and remaining all or z. So and again we have to check for the u, v power I and z, x, y power I and z. So finally, if you have the values, so here the first three values are u and the first second as it is we are writing, and I is equal to 2 we will take. So v power I, so v power v is nothing but 0 2's and 0 2 power 2 and 1, and y also y is equal to 1 power, so two ones which are having the power 2 and remaining all 0 0 0 0 0 and 1 1 1 1. So this is, and after that what we got, so 0 2's and we will name it as a 0 power 7 and 1 1 1 1 1 1 1. So here how many ones are there? Here 1 also, 0 power 1 power 7, and here 0 power 5 and 1 power 5. So what we got? So first W is followed by, so here the L is equal to W which is followed by another word. So here if we have here, if you take this first string, so 0 power P which is followed 1 power 0 power P 1 power P and 0 power followed by 0 power P and 1 power P. So P values is not changed here, but here if you take after the extraction what we got, so here 0 power P is not equivalent. So here P is not, values of first part and second part is not equal, so that we can say that the given language is not a regular context free language. So this is how we have to take the conditions and multiple conditions while taking that 5 string into a 5 parts, and we have to check for every condition whether the given language is a context free language or not, with this all the conditions. So this is about the pumping lemma of the context free grammar, and these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.